Okay, it's 4:01, so I think we're going to get started. So good afternoon. I'm Gloria Waters, Vice President and Associate Provost for Research, and I'd like to welcome you to this first research event that we're having this year. Today's event is not quite our usual research on tap. Um, Rather, it's a slightly different format. In talking with Eric, it seemed like there was a need for sort of more substantive talks in this area. And so the format today is going to be such that we have a smaller number of speakers, and each speaker is going to talk for 10 minutes. So as you can see, the talk and the topic today is on convergence and collaboration in cloud computing, data security, and also artificial intelligence. So currently there's a lot of work happening on cloud computing, data security, and also AI. And these are pillars of the work that we're doing in computing and data science at BU and also at the Hariri Institute. So basically the focus today is on how to make sure that data is not siloed, but how to bring together the fields of cloud computing, data security, and AI, and especially how the Hariri Institute can work to build collaborations around work in each of these different areas. So we're going to have 4 presentations, each for 10 minutes, starting with Eric from the Hariri Institute, then Oran Krieger, who's going to talk about cloud computing, Mayank Varia, who will talk about privacy and security, and Kate Sayenko, who's going to talk about AI. And then it's going to be followed by a Q&A, which is going to be facilitated by Eric. So Eric.
Great. Thank you, Gloria, for the invitation for us to do this. This is an area of research on campus, actually globally, but on campus and at the Hariri Institute in particular, that we have tremendous synergies around right now, and they are very much both an area of convergence in and of themselves, and more so they are facilitating convergence much more broadly in the data sciences. So we're really excited to be able to have this opportunity to talk with people a little bit and talk about what's going on and what opportunities there are for other things to go on. So if I can have the next slide, please. And as Gloria outlined here, we've got representatives from each of the areas around cloud, privacy, security, and AI here to come talk to you. I'm going to start us off by giving a little bit of a primer on the Institute, since it may be that some of you are not aware of some of the different things we're doing. Particularly, we have a number of new things we're rolling out this fall semester. And then towards the end there, what we'll do is we'll have sort of a panel style discussion and Q&A. So if I can have the next slide, and maybe right into the first content slide. Next one as well, please. Great, thank you. Okay, so 10,000 feet, what's the Institute about, right? The Hariri Institute for Computing at BU is dedicated to leading integrated initiatives, right? These are initiatives at the research and technology interface across a broad set of disciplines, and particularly at the nexus of where computing and data science sit, right? If it is computing enabled, if it's data driven, this is where we're looking to reside. Put another way, the Institute is also meant to operate as sort of a computational lens, if you will. It's a lens both to magnify what's going on campus and conversely to allow others to sort of see and integrate with what's going on campus beyond the BU infrastructure. Next slide, please. So we have a variety of mechanisms and resources at our disposal. We have a number of thematic research centers and initiatives. We have year-long focused research programs that we've just started this year. We have the capacity for software and data science development and collaboration with researchers on campus. Although this is less so at the moment with COVID and all of us, we have lab space, office space, we have state-of-the-art conferencing capabilities. And so most importantly these days, in place of those, we have Zoom. And we have, in addition to that, a variety of staff capabilities. So next slide, please. Right, powering the Institute is investment in the various parts of infrastructure that you need to help the research succeed, right? So we have a variety of staff supporting and nurturing fledgling initiatives all the way up to mature centers and initiatives. These help us amplify faculty research, support the grant strategies and submissions and management. They help us with event planning and promotion like what we are doing today. And of course, the variety of supporting financial and legal. Next slide. So let's take a closer look at the elements that provide opportunities for where the community can plug in. And I've highlighted 4 of them here: centers, initiatives, and labs, focused research programs, and then 2 new seminar series for this year. The first one is a Did You Know You Could series. And I'll tell you what the ... stands for in a moment. And then a Hariri Institute Distinguished Speaker series. And these are all being done virtually right now. Looking forward, we were just talking before this call, as with everyone, we're learning a lot about what we can and can't do in the current environment. And there are lots of things that we wish we could do. But I think we're also finding a lot of things with the virtual setting that we can bring back when we're back to more of a new normal. And I would anticipate a lot of these types of things to be hybrid going forward at the Institute. So next slide. All right, so let's start with our Institute centers, initiatives, and labs. One way to view the Institute as sort of an umbrella that sits over a number of smaller entities that are cohesive entities around research areas and people and groups in and of themselves. Going back to the birth of the Institute in 2011, there were 2 pre-existing centers that joined us, the Center for Computational Science and Risks, which is a center around information systems and information security. As we've gone through over the ensuing 9 years, there's been a number of other initiatives and centers that have both come into being and sometimes spun off and moved off into other places. So cloud computing is one of the first initiatives that came on board right after the Institute was founded, and that has evolved in several different ways. I would say currently its most visible form is through the Red Hat Collaboratory, which is currently a 5-year, $5 million collaboration with Red Hat. So that's been an amazing partnership. We also have partnerships with the City of Boston through our Boston Women's Workforce Council relationship. We have relationships previously with Spark, which has now spun off to join the Faculty of Computing and Data Sciences, although of course there's close relationships to this day. SAIL, which is our Software and Application Innovation Lab, is where we have a in-house software development capabilities, and they have integrated and collaborated with a variety of researchers across campus. All right, next slide, please. Next slide. Thank you. All right, so new to this year is our so-called focused research programs. Right, this is a way of taking research money and aiming it at medium to large groups around year-long efforts and themes. And the idea is to do this aligned with BU strategic priorities and or emerging opportunities. So these could be priorities that have been identified, or they could be priorities that should have been identified, and they're emerging and they're things that we want to get out in front on. They're meant to be umbrellas over perhaps several verticals, if you will, where there's interrelated sub-themes. And the notion of these focused research groups is that there are working groups at the core, right? So this is basically a supported infrastructure to help a medium to moderately large team of people work across the year, getting from where they are today, call that A, to somewhere else and call that B, right? And ideally B is somewhere you want to be to achieve greater visibility, to be more competitive for funding, to provide convergence in research areas that we didn't have it. For the academic year 2021, the inaugural programs in this space are a program on scientific machine learning for chemistry and materials science. This is being led by Emily Ryan and Aaron Beeler. And then a program on AI in medicine, particularly at the interface where bias around data and AI meet questions of equity around underserved populations. And Yanis Pashilidis is leading this with a number of other investigators in that space. So when we launch these, what you will see forthcoming through all sorts of different communication channels is you'll see a variety of different ways to be involved in these, from seminars to workshops and whatnot. So keep your eyes peeled for more about this. Next slide, please. We have 2 new seminar series this year. One is called a Did You Know You Could series. It's intentionally meant to be tongue-in-cheek, right? It's meant for anyone. It's being organized by our graduate student fellows. It was intended to be a brown bag lunch series. Now that's sort of a virtual brown bag lunch series. It's going on monthly right now. And it's meant to fill in the blank with small focus type of topics that you didn't even know you'd like to know about. And so some of the ones we have coming down the pipe are anything from did you know you could organize your software and development around GitHub to did you know you could represent languages geometrically. And so these are meant to be 1-hour sessions in which there'll only be 20 minutes of formal presentation. It is largely meant to be a meet and learn experience, and it's meant to be accessible to anyone who wants to join us on this. Next slide, please. On the other side of the spectrum, we have a Hariri Institute Distinguished Speaker Series. This is organized by our junior faculty fellows. These are intended to be clusters of broadly accessible talks. They are particularly focused on groups of up and coming movers and shakers, if you will. We'll have one of these per semester, 3 talks clustered over 2 weeks, followed by getting all the speakers together in a group panel discussion. The idea is to shine a major spotlight on major challenges and emerging solutions in computing enabled spaces. The particular topic that we're looking to have come out in December or perhaps early January is around AI and equity, and particularly focused on solutions in that space. Next slide. So at the Institute, there's different ways you can slice and dice the variety of strengths and resources that we bring to bear. One way that I find particularly useful when you talk from a research point of view and is what's really defined the organization of rest of today's event is in terms of areas of core computing strength, right? And so from that perspective, right, you can picture what we have here as saying that cloud computing, cybersecurity, privacy, and AI really are sub-umbrellas that, that capture key areas of strength, both at the Institute and by extension, of course, across campus. And the emphasis there is on both development of those core areas where we have amazing research going on and building those core strengths fundamentally, and also in how they integrate, support, and enable domain applications. And so what today's event is about is really about the activity and the impact and the potential around that core. And so next slide then. Right, we're going to start off then with Oran Krieger telling us a bit about cloud computing.
Hey, welcome everybody. So cloud is about sort of moving computers over the internet and accessing them at scale. And it's, you know, a user of cloud can get more computers or release computers, and they pay exactly what they need. And meanwhile, the cloud provider can purchase computers in large quantities, can locate them where power is cheap, where it has good networking bandwidth. So the economics become really compelling. A lot of people believe that the future of all computing is going to be in the cloud. A decade from now, we may not be able to buy a computer unless we just rent it out of the cloud. So that's great. Next slide, please. We've had this really unique opportunity. The institutions in this region, so Boston University, Harvard, MIT, Northeastern, and UMass, together built a data center, a unique data center. It's 1.5 acres, it's 15 megawatts. It's got capacity that's available to no other group of institutions around the country. And so we had a unique opportunity to build a cloud there, a cloud that could be used by hundreds of thousands of students. The economics are really compelling. If you look and you take a computer, or $1 million worth of computer, you amortize it over 3 years, the cost of it, the cost of an administrator, it works out to be about 20 times cheaper to have a computer that we stand up rather than buying the equivalent computational power in the cloud. Storage and networking are even a better story than that. So if we could create a cloud that was cost effective, that would enable much more economic research computing. For us as cloud researchers or security researchers, or even as AI researchers, it gives us the potential to transform the infrastructure, to do research into the plumbing of clouds. We don't want a world where in the future there's only 3 entities that control all the world computing. So it's been really powerful because we've been able to apply as a group of researchers for grants that you couldn't do unless you had your own opportunity to do that. And the side effect of that is most of industry is actually not able to participate in the public cloud. So we've had enormous connections from a whole bunch of companies who've wanted to participate in our cloud. So it's led to a whole bunch of NSF, NIH, and industry grants. It's led to the Red Hat Collaboratory and hundreds of computers donated by different partners of the MOC. Next chart, please. So today it's relatively modest. It has a bunch of core partners involved in the effort. It supports dozens of researchers doing cloud computing, and it supports about 400 users on average at any given time, and about 10,000 users of services stood up by that. So we're pretty happy. It's been sort of successful at a modest scale. Next chart, please. And this has really been sort of a stone soup kind of effort where different entities have helped stand up all kinds of different capabilities. We have about 2,500 cores of compute, of standard Intel compute, about 1 petabyte of storage. On top of that, we stood up storage services, VM services, container services, and actually recently we moved towards a productized service to allow you to actually acquire physical machines for deterministic research. That's been the participation of a whole bunch of companies that have actually worked with us to stand up those different services. Next chart, please. On top of that, Red Hat recently sort of made available an AI as a service offering, Open Data Hub. And it's actually really exciting because they want this to be a product. Out of their experience with doing this, they realized they really need to stand up services with real users to real customers before they start releasing these things as product. So they're moving towards operate first effort, where every product that Red Hat's going to be released will first be operated on the MOC before being released as product. Next slide, please. IBM last year donated a bunch of servers with 1 terabyte of memory in each, 40 NVIDIA GPUs, massive bandwidth between these. We've been standing up OpenShift and different services on top of that. And so this is an awesome platform for AI. Next chart, please. And Harvard Dataverse is actually moving off of AWS. So this is the largest dataset repository for a broad set of datasets. And that's actually moving off of AWS onto the MOC. And this will allow them to host large datasets and actually download them without paying egress costs from AWS. Next chart, please. Finally, the Northeastern Storage Exchange, which isn't us, but is a group that's working closely with us, standing up a massive data lake, so 20 petabytes. And again, the cost here is a fraction of the cost of S3. Next chart. So this is the project as it sort of existed, I guess, early last year. You know, as I said, a modest group of users, core set of partners, and a set of cloud researchers. Next chart. In October of last year, we got funding from the NSF to create the Open Cloud Testbed. So this will be a national testbed for cloud computing research, opening up the MOC to all the size researchers across the country. As a result of that, some of our industry partners added another 200 servers to the MOC. So this is actually reaching one of the largest test beds for cloud computing research almost from its inception. Next chart. So open source is difficult. It's really hard to operate this stuff. Those of you who have been our users have seen a number of failures over the years. We went to talk to the OpenStack Foundation about this, and we thought they'd be kind of offended, and they were really excited about it. We said, you guys really need a cloud to be standardizing things, to be prescriptive with. The Open Infrastructure Labs project was announced late last year, and we're giving a keynote in front of 10,000 people next week, so I'm a little nervous. This is a project which will actually, industry can participate with us to create prescriptive efforts. The goal is to actually standardize those and then replicate them to different academic institutions to start off with, so they're federated together. So this is going to broaden the MOC way beyond the core partners that we have today. Next chart. And this is perhaps the thing I'm most excited about the transformation, is that this has been a soft money project, a research project. Now we have BU's research computing and Harvard research computing are working together to create a production offering that will make this available not only to a much larger community that doesn't have the skills necessarily of people that have been able to use the MOC so far, but is actually in a professional research computing staff that have facilitators that can work with scientists to transform their computation to use the cloud. So we're really excited. All these efforts that I just talked about sort of came about since October of last year, and it's really expanding dramatically what we've been doing. And I think the key part about this is we're in a unique position in this area to do computing, to do research in an area that nobody else has access to a real operational cloud. Next chart. Oh, yeah, I forgot about this. And then finally, Red Hat has denounced their operate first policy, which is, as I said, around their AI platform. They want all their products to be first operated by Red Hat with users from academia on top of the MOC and operated, and so they can test them with real users before they release them into products. So that's a really huge infusion, and all this is resulting in, I think, a dramatic expansion, which I hope we'll be able to announce soon with the Red Hat Collaboratory. That's it. Thanks. Next chart. Okay, that was it.
Great. Thank you, Oren. Excellent. Yeah, there's tremendous possibilities for us around cloud here at BU. One of those is interaction with security and privacy. And this is something that, as Mayank will tell you in a moment, is something they already have quite a head start on. There's exciting things that are already done and a lot of other additional exciting things that could be done. So Mayank?
Yes, thank you. So yeah, I'm Mayank Varia. Ostensibly, I'm the person who's talking about the data security part of the theme for today. And the project I want to discuss, it's great that Oran just spoke. This is I want to talk about a project that the two of us have been working on together for the past few years, together also with the Hariri Institute and specifically SAIL. It's a just completed $1 million NSF grant to work on taking the ideas of data security and privacy that I do and combining it, putting it on the cloud data center. Next slide. So the general theme of what I want to discuss today are situations where you want to achieve a strong utility like cost effectiveness, as Oran mentioned earlier, by moving your data to the cloud, but you're still concerned about privacy. So for instance, a project that we've been working on with the city of Boston for the past several years, helping companies compute the average salary across the city of Boston without exposing the salary data of any company, or for example, medical scenarios that we're currently in talks with healthcare professionals about, of like helping researchers in hospitals to generate aggregate statistics about how a disease is spreading throughout the state without revealing individual data at the individual patient or hospital level. So the common theme here is the organizations want to be able to leverage the power of the public clouds, everything that Oran just mentioned, but they don't have, they either don't want to or cannot, are legally not allowed to entrust a single cloud provider with all their data. Next slide. And so the starting point of our collaboration came from sort of looking at the work that Oran is already doing together with the Harvard Dataverse project on bringing together a lot of very useful, especially social science data sets onto the public cloud. So Harvard's Dataverse is one of the largest social science repositories of open source social science data in the world. And the Mass Open Cloud is a great place where anyone can not only download that data, but also compute over it in situ. Next slide. And so the goal of this specific project is to combine that idea of harnessing the power of data storage and cloud computing, and data storage and computing on the cloud, and combine it with the work that I do on cryptographically secure multi-party computation, which I'll describe next. Next slide. And MPC, Secure Multi-Party Computation, or MPC, is a really cool technology, I think, that allows a group of computing parties or group of data holders to work together to learn collaboratively some kind of statistic over their data without sharing it with each other or without entrusting it to any other party. And the basic idea of how it works is that every single person who has some data, they encode and split their data across multiple computing parties. And these encodings have two properties. First, the encodings have the property that any individual server's component of the encoding just looks like random gobbledygook. It looks like garbage. But second, it has the property that together, all of these encodings have the property that the servers working together can actually do any arbitrary statistics, any computation over them that they want. So sort of, it allows them collaboratively to do data analysis without individually learning anything. So it allows them not to have to put their trust in any single trusted third party. Next slide. And so over the past few years, we've been working on a software project that we call Conclave, which is about trying to do secure multi-party computation, realize the benefits of this cryptographic technology at scale, at data at the millions to billions of records scale. And we have this package called Conclave that we think does a very nice job of this. It allows people specifically to do relational algebra queries, so to compute things in the structured query language or SQL. So you can type in a SQL query more or less without having to know anything about how cryptography works. And under the hood, there's a bunch of tools to provision the execution of secure multi-party computation and optimize it behind the scenes so that it runs as fast as possible and the tasks get dispatched to the backends that will execute the jobs. Next slide. So, oops, I wrote these benefits in the wrong order, copy paste fail there. But so we think that the benefit of putting together this work in secure multi-party computation together with Dataverse and with the Mass Open Cloud allows us to realize something really neat. By working on the Mass Open Cloud, we get to leverage the benefits of an open cloud, a multi-provider cloud. So anyone can choose which part of this multi-provider cloud they wish to entrust with their own data. And by working in a place that already has access to the Cloud Dataverse instance, we can bring cryptographically protected computing to where the data already live. Next slide. So the conceptual workflow of the product that we've been able to put together works as follows. So I'll describe a medical example. So here on the left side of the slide, there's a hospital, Boston Children's Hospital. And let's say they want to upload their data to the cloud. Ordinarily, they would just put their data in something like Dataverse. But let's say they don't want to put their data, in the clear in a place where everyone can see it because there's a lot of sensitive protected health information there. So what they do is they put encrypted data in the cloud. So Dataverse can host and index and make available the knowledge of the existence of this data set to other people without actually learning any of the data. And maybe Boston Children's Hospital decides, I'm willing to entrust just the Harvard pod within this multi-provider data center within the MOC to see this data. So only this Harvard pod gets the keys to be able to decrypt its data. And similarly, there's another hospital, let's say MGH, that does the same and has a different provider that they're willing to entrust with their data. Next slide. And then suppose somebody else who doesn't work at either of those two hospitals, maybe a BU School of Medicine medical researcher, comes and says, I have an interesting query that needs to aggregate data across these hospitals to test about, links between a disease A and disease B, or symptom A and vaccine B, or whatever. So they can type in this SQL query, and our Conclave system now running on Cloud Dataverse will automatically behind the scenes fetch all the relevant data sets that the querier is asking about, and will spawn a computing job, will spawn the OpenShift containers on these different pods that will run a secure multi-party computation within the data center, but between the different pieces of the data center, so that the data owners know that their data is never revealed to anybody, not the researcher, not to Dataverse, not to anybody other than the pod that they're willing to entrust. And the medical researcher can get the results, the statistical results of that query without ever needing to have either the access, without needing to see the data and without really wanting to see the data. And so that's basically the punchline of what we've built. Next slide. Just in conclusion, I just want to say, like, this takeaway of this technology that I think is really cool of secure multi-party computation. The punchline is that it allows us to derive knowledge from data without having to entrust it with a third party. This opens up lots of avenues for being able to gain social value from data that is encumbered either by some kind of legal restriction or corporate competitive restriction or social or ethical restriction, etc. Next slide. And the software products that we've built as part of this collaborative project are all available on GitHub. Thank you.
Wonderful. Thank you, Mayank. So if where you can do your computing and in what environment is being transformed through cloud, and how you can compute in ways that break down barriers that are in place due to questions of governance or compliance or ownership are being broken down, then at the same time, what's evolving at a tremendous pace is just what we can do with that data. And the variety of different data types we're finding that we can work with and integrate. And so that's broadly being placed under what these days is called an AI umbrella sometimes. And Kate Sayenko is going to tell us more about what's going on in AI here at BU.
Hi, everyone. So yeah, I work in AI broadly, and I'm going to tell you a little bit about different projects that we have going on both in my group and in other groups of faculty who do AI related stuff. So if we can go to the next slide, please. Thank you. So there is a large group of faculty at BU who work on artificial intelligence. And this is a very broad area, of course, but some of the more narrow topics include deep learning, supervised and semi-supervised learning, active learning, domain adaptation, which is something I work on a lot, learning embeddings of data, learning encoder-decoder models, adversarial networks. So all of these are essentially things related to deep learning with applications to image, video, and text data. Next slide, please. So here are some of those applications. This is just a sampling again, but it includes, projects such as understanding animal behavior, retrieving images or videos based on their descriptions, or detecting racial and gender bias in AI algorithms, in more generally kind of natural language understanding for various applications, or video understanding, image understanding. And so there are lots of different applications, but most of the research we do, is core research that develops new models to enable these kinds of things. Next slide, please. I'll just feature a couple of selected projects. So this one is on taking deep neural networks, which are the standard AI technique these days, and trying to make them more explainable to the average user who doesn't know anything about how they work. So this will address questions like, can a machine learning method explain its output? So why does it think there is an elephant in this picture? Or why does it think that a lady is running in a video? Is it actually recognizing a person and recognizing that it's a woman, or is it just kind of using some data set bias and guessing that it's a lady but doesn't actually know for sure? So all of these are questions that users might ask when they interact with an AI model. Why is it making certain predictions? Next slide, please. And here's another project that I'll briefly feature, which is applying AI and specifically computer vision techniques for tracking objects in images and video to understand animal behavior. In this case, understand how bats fly, and tracking their trajectories, and automatically as you can see, there could be a lot of these animals in one particular colony. I don't actually know the specific term for a bunch of bats, but it's a very difficult problem to track all of them individually and how their trajectories are actually changing. So this is one example where automatic computer vision techniques can help us understand animal behavior. Next slide, please. And then again, in my own research, I'll highlight a couple of projects. Next slide. So one thing that I'm really interested in is understanding both images and language and connecting those two modalities. So one of the applications is automatic captioning of images or automatic captioning of videos. So generating language that describes the content of those images and videos. Another application could be finding specific images based on descriptions or finding video clips based on descriptions. And then we also work on multilingual language and video and image understanding. So if I wanted to, for example, find an image based on a description, not just in English, but in any other language, can I do that efficiently using AI techniques? And then another recent project that I have in my group is applying understanding of language and images to detect news articles that were generated automatically. So we call these neural fake news because they're generated by AI models and they're not actually composed by humans. So next slide, please. So another approach, another kind of research area that I'm interested in is understanding how we can train AI models on one data set or a set of data sets and then transfer that knowledge to new data. Because data is very expensive to collect. It's very time consuming and expensive to annotate. As anyone who's applied AI to their own problem can tell you. So we would ideally like to avoid AI models overfitting to their training data, which they tend to do. We'd like to transfer the knowledge and adapt the knowledge so that their performance doesn't fail because they get some data that they hadn't seen in training. So this could be going from one data set to another, or from simulation to reality, or even from one demographic to another. So all of these shifts will affect AI performance negatively. So trying to improve that. Next slide. And then part of that is also transferring AI models from simulation to reality. This is just one type of domain shift. So one of the applications here is to robotics, to picking up objects where we can train a robotic arm or train a neural network that controls a robotic arm to pick up objects or manipulate objects, and do that in simulation because it's cheaper, it's safer, it doesn't damage the robot hardware. But then we want to transfer that neural network, once it's been trained, to a real robot where it observes real images. So that's a transfer learning problem. Also, we worked on applying this to neural flight or using neural networks to control drones. Again, training the neural network in simulation and then transferring that to reality. Next slide, please. And then I believe this is my last slide. So here we can adapt these same kinds of techniques, but instead of analysis and decision making, we can do content creation and generation. So the left figure shows an approach that we developed where we can manipulate a video of someone or image of someone and change their facial expression. So you might have heard of this as a kind of deep fake technology, but deep fake sometimes swap the entire face. Here, we're just manipulating the person's facial expression or making their mouth either open or closed using this automatic approach. And on the right, we can also generate images of images that have a different style based on some input image. So here we have a style of one animal species, like a dog here, and then we have the content or the pose of another dog, and we want to combine them and create a new dog that doesn't actually exist, but has the same pose as our content image and the same style as our style image. So that's another way to create new content using AI techniques. So I believe that's my last slide. Yes, thank you very much.
Okay, thank you, Kate. And thank you again to all three speakers. So we're going to move to the panel portion and Q&A. So I would encourage you, there's a Q&A feature on the Zoom. A couple of you have been using it already. I'd encourage you, if you have questions, to please put them there. I'm going to kick us off with an initial question just to get some discussion going, and then we'll be keeping an eye on the Q&A box here. And either we'll repeat your questions as they are, or if there's some commonality, we may pull them together and cast them as a single question together. So if you have questions for the speakers or myself, please do put that in the Q&A. To kick us off here, right, I have to say, you know, having been director of the Institute since January, that probably the thing I've most enjoyed so far in these 6 months or so is the opportunities I've had all over campus to sit down with people, hear about the research that's being done, hear about what pain points or challenges or opportunities there are, and think about how to solve them. And one of the things that struck me is so much of how often what's being talked about in terms of challenges seem to revolve around questions of data sharing and increasingly what is now becoming called model sharing. Data sharing and model sharing, breaking down data silos, as Gloria was talking about, is something that really is a change that's running through global society. I think the momentum behind that has been substantially augmented in the wake of COVID-19 and the dialogue around race. And so I guess I would ask the panelists, if we could for a bit, is talk about how cloud, privacy, and AI are being impacted on the one hand by, but also enabling on the other hand, the sea change in thinking about sharing of data, sharing of models. And by extension, then what sort of opportunities are there either research within the university or research opportunities perhaps with other partners outside the university?
I guess starting from the plumbing layer, from the bottom, the cloud. I mean, we have, you know, Dataverse is coming onto the platform because the economics are compelling, I guess. But that cloud, even without that, gives opportunity for anybody to share a data set with specific other entity for discovering even the data sets. You know, so the amount of effort people do to curate and build data sets are huge. One of the conversations that Mike and I have had with various hospitals is, you know, the idea of sharing data to deal with sort of rare diseases and stuff has been there for decades. And we met with one of the CIOs, I guess, of one of the hospitals, and he was sort of saying, yeah, people, you guys don't want me to do this again. Yeah, everybody always tells me we never are going to do it. You know, we're just not going to share data. We're not going to provide any platform. And so we kind of talked about, well, what if we gave you an enclave that was totally isolated, but you could just have a lot more computing power there and it was cheap and you encrypted your data? And he was, yeah, okay, I can buy into that. And then the next step was Mike describing the multi-party computing capability and provable. He was saying, yeah, so I could buy into it bit by bit, but once I put my data in a common place, it's actually feasible to then choose to share a particular data set rather than sort of going through all the boundaries for just one data set. So I think we have a really unique opportunity there to sort of not force people to an all or nothing solution, but to get them into a shared environment where they can then sort of incrementally decide to make sharing decisions, or opening it up to just one AI researcher.
Yeah, Kate.
Yeah, I'll jump in and say, you know, so from my perspective as a security and privacy person, right, you asked the question about data sharing and model sharing. But what I hear is data breaches and model stealing, because this is how I think, right? But so that's always like the concern that I have whenever people talk about sharing. But I don't want to just be a naysayer, right? The objective here, you know, one way to prevent data sharing, data breaches and model stealing is to never share data at all and never use AI at all. But that's not a good answer to anything. So that's where I think, you know, sort of if I look back over the past decade, we sort of you know, have been in a space where there was sort of a platonic idealism of data sharing solving everything, and now there's a little bit maybe in the other direction, people being very worried about especially large tech companies who have too much data and the amount of control that they have, and that maybe we should put the brakes on data sharing. And what I'm interested in is how do we harness sort of those concerns about data sharing, but not turn it into sort of nihilism, not turn it into we should never share data, but turn it into how do we share data in the right way? How do we share the ability to gain knowledge from the common knowledge from the data that we all individually have? Just as Aran said, without like, just like he said with the example of the CIO of the hospital, how do we gain the ability to get the outcomes that we want without the downsides that we're all concerned with? And I think, since your question was about sort of the current momentum building up to time, I'm hoping that we can somehow harness the legitimate concerns that people have over data sharing, but say like there is an alternative to this like all or nothing world of data sharing. There's this middle ground that we can go toward.
So my take on data sharing is a little different, because I think in my field, it's not like in the medical field. It's not medical data. I don't work on medical computer vision. So it's mostly images, just regular photos that people take and upload to various social media sites or just to the internet. And people haven't been as concerned about sharing those photos, at least most people. Although they're starting to become more concerned, I would say, or at least there's been some news coverage of, some activists who, had found that ImageNet, which is the largest collection of images that's used in academia to train image recognition models, that it has images, it has photos of people who didn't know that their photos were in ImageNet or being used to train AI. And there has been some activism also around kind of just using people's actual face, like data with people's faces, or images that record people and their activities. So even though right now, people aren't really concerned and they just share this data freely, it's uploaded, it's on YouTube, it's everywhere, you can just download it. Maybe it's going towards more of a world where we're maybe, at least for some of the data sets, we're more careful and we can't actually release them. Like one example of that is, maybe research that really involves something more sensitive, like deep fakes, applied to people. And maybe that's something we don't want to freely share, because that could get into the wrong hands.
Great, thank you. We have a lot of people on the call with us that are from various areas of medicine or health on campus in terms of investments, whether it's Sargent or social work or public health or med. Realizing, of course, that none of us in this so-called room here are medical people. Can you comment a little bit from your experience in terms of any additional challenges you see regarding what you've been able to do or might like to do in the medical space? We have HIPAA, of course. We have various related ethical concerns and such. So is there anything you can comment on in that direction, either by constraints and challenges or by way of opportunities?
I can comment on an opportunity, something that we're currently looking at, and it sort of relates to a different convergence that we haven't discussed yet, which is the work that several of us in Hariri are doing together with folks in the law school, and understanding the legal implications of the use of technology in general and cybersecurity specifically, in my case. So we have been looking, for instance, at the question of how does the use of cryptographically protected computing relate to sectoral privacy laws in the United States, in particular HIPAA, which you mentioned. And so we've been talking with one of the people who is a HIPAA expert determiner, one of the people who certifies whether different types of data flows and data computing flows are consistent and allowable under the HIPAA privacy rule. And we've been talking with him about how secure multi-party computation works. And we have sort of a working theory in progress that actually, if you use secure multi-party computation on protected health information, it might be the case that that lowers, does not eliminate, of course, but lowers the legal barriers to the use and dissemination of information that results from it, especially when used for medical researchers to try to make queries on data for hospitals. So I think there's a lot of opportunity here for understanding the extent to which, with good cybersecurity hygiene, we can design systems that can be both HIPAA compliant and allow for more expressiveness of making use of data than before. Whereas currently, I think HIPAA's compliance tends to be a lot of just siloing data off so that other people can't use it.
Kate, Warren, any comments? No? Okay. Let me query you on a challenge I know we all have there when we're operating at this convergence that we are here, and it's a good challenge, but it's one that we can all continue to work at, and that's the challenge around translation. Right, so there's both core fundamental research going on within cloud, within privacy security, within AI, and there's cross-disciplinary research. Can you talk a little bit to some of both the opportunities for that and the pain points? What makes it harder? What makes it easier? Because I think presumably there's a good mix of people on in the event here today of both interest in core type research around these topics and interested at the translational forefront. And as you all know, and I can tell everyone here, the Hariri Institute is particularly interested in trying to help move forward on convergence, and that means tackling the translational angle. And that's something that really is sort of a collective effort in order for us to move forward.
So that was me, Eric, that you wanted to? So one of the things that building systems is actually sort of a challenge, like building computer systems that can be realistic enough that other people can actually use them. And we've certainly faced that challenge with the mass open cloud, especially our early users would attest to that. But one of the things is it's really hard to do good systems research without sort of, solving the circular horse problem, for those of you aware of that joke. We want to do something that people can actually use. And to do that, one of the things that we found really valuable is to work with industry. So a lot of our stuff, like the early things we did in elastic scalable infrastructure or in unikernels, were done as pure research projects by a group of PhD students working with some faculty. We've then engaged with Red Hat and with some of our other industry partners, but particularly with Red Hat, where they got engineers working with us to integrate these ideas into a larger, more complex open source software platform that can be then deployed for real. Because if we don't have something like that, it doesn't really make sense for Mike to be working on security stuff on some exotic research platform, or for Kate to be doing AI on sort of hardware we put together ourselves. There's this multiplication of risk by having research projects depend on each other. So I think that that's a really important thing. And we've had the innovation we've done in the storage stack gone upstream and into the Ceph community. The mechanisms we've built for sharing infrastructure between clusters have now made it into the OpenStack Ironic project. And we expect to see a lot more of that. That's the way sort of we feel we can have an impact, not just by publications, but by actually transforming things into open source communities. And that's the beauty about the nature of our field, is that everything today is moving in open source. So engaging with a community of researchers is one thing, but the next stage of getting an open source community to buy into your innovation and develop something that can actually be used by other people has been, I think, both one of the biggest challenges I've faced coming back to academia from industry, but also incredibly gratifying. I don't know if that addresses your question, Eric. Was that?
No, that's great. Thank you. Yeah. Kate, any thoughts on challenges and opportunities around translating from core AI or privacy research across boundaries?
I guess I haven't done really much translational research like that, so I'm not really sure what the pain points would be. Yeah, I don't know. I mean, one thing is just kind of knowing what the interesting problem is, and is it interesting from machine learning or AI perspective.
Mm-hmm. I think one I have particularly in mind regarding AI, Kate, is, and you and I have talked in sort of research context a bit about some of this, is the incredible focus these days around equity and bias in AI, and the fact that some of your research and others, of course, is focusing on all sorts of various viewpoints around rebalancing data or learning, taking learning from one context, transferring to another context. How robust do you feel that area is right now? If we were to sort of cast it open from a domain perspective, I think hopefully everyone is looking at their data right now and saying, how fair are our data, how representative are our data, and if they're not, and people are then looking to AI for solutions, how ready do you feel that portion of AI research is? So you may be muted. We're not hearing you.
Oh. No.
There it is. Yeah. Yeah. Now we got you. Nope. Back out again.
Let me try this. Is this any better?
There it is. Yeah. Yeah.
Okay. Sorry about that. So I think that it's hard for me as someone who's been doing research in AI for a long time, more than 15 years. It's hard for me to see it as a product. So whenever people say, oh, we think AI, is biased, or we think it fails sometimes, my reaction is, yes, of course. It's not a solved problem. It has a lot of limitations. So, this data set bias is something I've been researching for over 10 years, and I don't have a solution yet. So, like maybe I'm the wrong person to ask, what the limitations are, because that's all I see. That's my research. I see the limitations in it. And, I think there are some solutions, but, from my perspective, we're nowhere near done with that. And we just have to do a lot more research on it.
So is it fair? It sounds like perhaps that this still is at a level it needs to be taken case by case, at least, or area by area.
Yeah, I think there are some applications where data set bias is less of an issue. For example, search is one of these, or like if I'm looking for pictures of cats, and I don't get precisely the cat that I was interested in, that's kind of a mistake by the AI algorithm, but it doesn't cause anyone harm, and I'm still going to use the algorithm because it gives me enough value, but it's a low stakes kind of application. But if that same algorithm is being used to, detect cats, to, stop a vehicle so it doesn't run over the cat, and it fails to detect the cat, that's a high stakes application. And, I wouldn't use AI exclusively for that because I don't think it's going to be 100% correct in all cases. It's going to be good for the cases that are similar to the data it was trained on, but it's not going to generalize all the time. So I think it just really depends. I think for certain applications, AI is pretty good, and even as a product, of course, but there are some that maybe just shouldn't be used exclusively automatically, and there should be users in the loop or humans in the loop that kind of moderate and make the final decision.
Great, thank you. Mayank, I know you've definitely had experience in the translational space with some of our the Institute's work with Boston Women's Workforce Council and others. Any thoughts on challenges and benefits in doing that?
Yeah, I'll just say that briefly, since I know we're at the end of the hour, that there's a nice symbiosis that I've seen over the time I've been at BU with industry partnerships in particular. That industry, because we're a university and in particular Hariri does so many cool things around computing, that industry partners who come in the door through one part of Hariri can often find interesting problems to work on with others. So for instance, Oran has been working for years now with the wonderful folks at Red Hat. And when that started, I didn't expect that I would end up, doing any data privacy work with Red Hat. And I'm sure Hugh Brock and the others at Red Hat were not expecting that as well. But we've had an enjoyable time working together. And I've worked with some folks at Honda Research Institutes, and one day we were talking and they had a problem involving transfer learning, and I was like, oh, I know exactly who you should talk to, right? And so we had a meeting introducing them to Kate. So it's the nice thing about working at an institution like ours is that industry partners who come in often get more than what they initially bargained for, but hopefully in a good way.
Great. I'm taking a look at some of the comments and questions that are coming in. Let me try and formulate a couple of them. So Aran, I think one thing that I've seen in a couple of the questions, I know you've answered them specifically in the Q&A box, but how does what you're doing with the MOC and the larger ecosystem now around that, how does that relate to what's going on in the professional cloud provider and service space? And for a BU researcher trying to figure out, should they be looking towards AWS, or should they be looking to do something integrative here at BU? I mean, how does one sort of sort through that? What are the relationships, and how does one sort through those relationships?
So when cloud started out, it was really about you get your VM up there. It was a pretty simple story. Now all of the public clouds have provided this enormous array of different services on top of themselves. And really, that's the only place where you can gain access to this wide variety of different services. What we're starting to get is through mechanisms like operators and OpenShift and Kubernetes, the capability for people to stand up themselves this wide array of services. But it's certainly not there yet to even come close to what the public cloud offers. I'd say if you want to use those services, you should certainly do that. One danger that I think we all face in using the public cloud is kind of the lock-in. It's free to move your data up to the cloud, but they charge you a lot to download your data from the cloud. And it's not because bits moving in one direction of the wire cost more than bits moving in the other direction of the wire. So everybody's right now in kind of trying to lock down the world into their public cloud, which is a bit scary. I think that we have the opportunity to, in the long run, and I'm really excited about the professional research computing staff at BU and Harvard starting to work together with us on this, but creating something that we really can create a good enough offering for many users, with the open source community working with us, like they're really starting to buy into it, creating something where we can create these cloud in a box solutions so that other institutions can stand up the same thing. We can federate between academic institutions. As we go to scale, we can offer a tremendous number of services. What do I believe in the distant future? In the distant future, I don't believe that we're going to be in a world where there's an oligopoly or monopoly of 4 or 5 companies that own the world's computing. I think there will be a federated open cloud model of some sort. We're kind of working in the early days of that. If you're brave, come and use us. If you want to, or if you're very economically stressed, we certainly are are there for that. But I think we're getting better and better, and I think we're going to satisfy a larger percentage of the use cases in the university. And I do think that that's really where the future is going to be, not in the MOC dominating the world, but in many entities federated into an open cloud where you're not locked into one entity. So, you know, if what we do is good enough for you, great. We'd love to see more users of these different services. If not, you should certainly use the cloud, but I think you should be careful not to lock yourself into one sort of vertically integrated entity.
Great, thank you, Aaron. Kate, we have a question around AI that I'm going to interpret in the following way. You mentioned the cat, and you mentioned two different variations on the cat, one which had sort of very low cost on errors and the other which had very high cost for errors. Are you able to speculate a bit on kind of what might be next coming up soon as kind of like the human in the loop solutions that would be sort of lowest hanging fruit that we might start seeing, where you know, there would be a fairly substantial reliance on AI, but the human is still in there? And what would that loop look like with the human?
Right. So I think, you know, we already have an example of this. I don't know if any of you have a home security system. But you know, it's one of the really simplest and basic applications of AI and computer vision, just detecting motion. And you know, these systems are getting better, but oftentimes people get them and then they turn off the motion detection because it keeps giving false alarms. But I think as they get better and better, we are going to have that as one of these systems where there is a human in the loop, because, you know, you're never going to hook it up to kind of like call 911 immediately, you know, as soon as it detects an intruder in your house. At least I don't see that happening in the near future, you know, because it's likely just to detect your teenage child who forgot to key in the code or something. And so, you know, it's going to alert you and say, hey, I detected something suspicious. Here it is. Take a look. And then you can decide if you're going to take action. So I think that's one. Self-driving cars, I think, are not coming in the next 10 years. At least I don't think that's going to happen. At least I'm not getting into one if there is one. But assisted, you know, driver assistance is already happening, right? So again, that's like I have a relatively new car, and it's constantly alerting me about things like cars behind me when I back up. And I find that useful sometimes, but then other times, you know, it just goes nuts because I have a bike rack on my car and it thinks there's something there when I'm backing up, right? And then I ignore it. So I think that's actually already the majority of cases where we are using AI all the time. You know, Siri, how many times Siri looked up the wrong recipe or played the wrong song? Like, we are very tolerant of that because we know AI fails, and we just kind of write it off as, oh, you know, that's just Siri, you know. We don't get upset about it. So I think that is already the norm, where AI is already being applied in many, many ways where there is a human in the loop. And it brings real value. But for those like really fully automated applications and really high stakes applications, you know, I think we have to be very careful, you know, and definitely keep the person in the loop for those as well. And, you know, until we're absolutely sure that this technology works. So yeah, that's my take on it.
Great, thank you. Yeah, you're describing your car, and I'm thinking, yes, this is why I still have an older model before a lot of those quote unquote improvements were on, because I find the help annoying. So Mayank, to turn things a different direction, you've referred a couple times just briefly to sort of the intersection with the area you're working in around security and privacy and questions around law and policy. And I know, of course, you and others are deeply involved with colleagues of ours in law and policy through the Institute Cyber Alliance initiative. can you talk a little more about what's going on right now that's really cutting edge in that space? What are the hard things that are being worked on that you think are coming down the pipeline to really start having an impact in the next either 1 year, 3 years, 5 years, 10 years? You know, what do you see happening in that space? That seems to be a space where you either know about it or you don't know about it. And if you do know about it, you're excited. If you don't know about it and someone tells you what's going on, you definitely know about the type of stuff that's going on. You just might not have known that the cybersecurity and the algorithms people were so deeply involved already.
Yeah, it's a great question. It's hard for me to pick what to discuss, so I'll sort of give a few answers. But yes, it's been great. We've had an ongoing dialogue with folks in the law school, in the Questrom School of Business Ethics, Questrom's Business Ethics, the Cecilia Institute within Questrom, and others. I think there's a lot of places where technology is influencing the law, or rather not like influencing like how people make laws, but like how people have to interpret laws and take sort of pre-digital era laws and figure out how to interpret them in a digital world. There's also a lot of places where the law is trying to figure out how to, so a good example of like how the law is having to sort of figure out how to deal with modern technology is the debate about encryption and law enforcement access to encrypted data, and the question of compelled decryption. Can the government force you to unlock your phone because they don't have the technological capability to read the data on your phone themselves, because that's what encryption does? And so can they force you to do it instead? So there's a very large ongoing body of work there, and a lot of the BU students and postdocs are actively writing in this space. There's also the space of law sort of trying to figure out how to regulate new technologies. That's a big topic nowadays. Social media and disinformation, misinformation campaigns are a big area of trying to figure out what is the appropriate role, if any, of governance there. But maybe the part I'll focus on and say like is maybe one of the most exciting to me is how can government itself harness these new capabilities, these new technological capabilities of in the public sector, in the U.S. federal government specifically. There's a lot of people in Congress and in the executive branch who are looking at the use of privacy preserving technologies to figure out how they can be both good stewards of the public data that is entrusted to the government, like say through the Census Bureau. And if you haven't filled out your census form yet, please do so today. It's the last day. Or through the IRS, which collects your, stores some sensitive financial data about you, of course, and others. So how can they be good data stewards? And how can they also be good at being transparent and providing evidence for why, like data-driven decisions, why the decisions they're making are driven by sound data? So government has this dueling objectives of transparency towards the citizens, and also protecting the privacy of the citizens' data that it's entrusted in their care. And so they're very interested in using technologies, including secure multi-party computation, which I talked about, including differential privacy, which our colleague Adam Smith is one of the inventors of, and has seen huge adoption over the past few years within especially the Census Bureau and starting to be other parts of government as well. So they're starting to look into this. For instance, there's a pending piece of legislation in the US Congress, well now, although Congress isn't going to vote on anything this year anymore, but which would actually affect us if it is passed, which is about understanding how financial implications of a college experience. So to aggregate salaries of recent college graduates by university or by major or by area of the country that they graduate from, et cetera, to provide data to prospective college students about the financial implications of a college degree. And that involves taking sensitive data of people's salary data as submitted to various government agencies who know about people's payrolls, and correlating that with educational data and educational records, right? Maybe even correlating it by GPA. That involves records that universities have and that the government does not, and is actually legally barred from acquiring from universities. And so the only way to accomplish a data analysis of that type is to use secure multi-party computation, which is what this pending legislation says to do. And that's just the tip of the iceberg. I think there are a lot of other places within the US federal government that are actively exploring how to use these privacy preserving technologies.
Great, thank you, Mac. And I want to swing maybe back to Kate and pick up on explainability, right? So explainability is definitely a word that's really become very much hinged to AI as well. And I know, Kate, you've worked in this area a bit. So the explainability of AI algorithms and output, where do you feel that is now and where does it need to go?
So I think it's still a very nascent research area, especially since in neural networks, we really struggle to explain their decisions. You know, they have millions, hundreds of millions of parameters that are doing some very complicated computation. So it's not something that any human being can understand. So the only thing we can really do is, right now at least, is try to trace back to the input and try to analyze the influence of the input of the model on the output, kind of removing parts of the input and seeing how it affects the model. And that gives us a kind of heat map over the, like if it's an image, it gives us a heat map over the image that says, well, this part of the image was important in producing the prediction and these other parts were less important. So it just kind of gives you a relative importance of different parts of the input. And you could do the same for text, you know, highlight pieces of the text that were important for them, that caused the model or are more correlated with the model's decision than other pieces of the text. But as these deep learning models are getting more complex, the trend is definitely to bigger, more complex. You know, the latest natural language models like GPT-3 are so large that, you know, they take weeks to train on very large amounts of hardware, and, you know, you probably burned a forest by the time you've trained one of them. And then they have just so many parameters, and they're even harder to explain. So I think the trend in the models themselves is towards larger and harder to understand, while we're still really behind in trying to understand them. And there's also, you know, there is a school of thought in the AI community that says, well, why should we even try to understand how these neural networks are making predictions? Because you know, we don't really understand how humans make decisions, and humans have actual neurons that fire in complicated ways. You know, we don't really understand, like, why did you wear this blue shirt, Kate, this morning? Why didn't you wear a red shirt? Can you even explain that to me? Right. So there is a school of thought that says we shouldn't even be trying to explain AI models as long as they work. But my counter to that is that they often don't work. And also, you know, we at some point might want to actually interact with them more. And if users start interacting with AI models and kind of teaching them things in a more interactive way, or trying to understand where the model is coming from so that they can trust the model better. Like if you had, you know, we're not there yet, but, you know, if you had a companion robot and you wanted to understand why it brought you a blue shirt and not something else, you might want to ask it. And, you know, it's not clear that we're going to want these, like, people are going to want these kinds of explanations, or they just want to know that the model is reliable and they don't really need an explanation. I think it really depends on the application. But if we want, you know, as we move maybe towards more interaction with these models, we're going to need kind of ways that humans can maybe not understand, but at least interact with the model in a way that can change its behavior. And that has to be explainable to a human, right? Because a regular user is not going to be able to run gradient descent on a model. They're just going to say, oh, I don't like blue, right? So, learn from that. So I think there's some combination of these things that that I find interesting, right? That's like some part explanation and part interaction, maybe.
Thank you, Kate. If we look at convergence as a theme, right, which is today's theme, there are so many different areas that one can touch on in terms of convergence. We have just a few more minutes left, and I wanted to maybe pick on one last theme. So sustainability and environmental impact and whatnot. That's something Kate mentioned at one point, burn a forest. This was not said in jest. There are studies, and Kate and others have been cited, quoted on this, where you take a look at the amount of computation needed to fit extraordinarily large models, and it's really, it's daunting. And at the same time, the sheer amount of hardware and the amount of energy and whatnot is also daunting. And sustainability is one of BU's primary focuses for the next 10 years in terms of strategic plans. So do you want to comment at all regarding how, and whether positively or negatively, right? Because how can computing and AI and security and cloud, how can that all perhaps interact with sustainability? Ron, do you have thoughts from a cloud perspective?
Sure. I mean, one of the things that happened back in enterprise data centers when I used to be at IBM. So the utilization of computers was on the order of about 5%. That was considered reasonable. In fact, it was really interesting because I was talking to the CIO of defense organization, and the utilization of their computers, he said, was 1/3 of 1%, the massive amount of computers that they have. And why? Well, it's because we're doing things in sort of small units. In the case of the defense contractor, it's because if you think about it, you don't want your fire trucks to be 99% utilized. That might be an efficient use of fire trucks, but it means that you'll have a long queue when you're actually trying to, a house is burning down, which almost happened to me last week. So it's, what cloud gives us is the opportunity to actually multiplex the resources, to actually share them. And the more we can build in the security mechanisms that Mike is talking about, so that the defense industry could, for example, they have all this infrastructure sitting there to deal with the national emergency. So would all of us be willing to spend 20% less on our computers if in the eventuality that there was a national emergency, we would immediately lose them? I think that probably Kate would say, yeah, I'd spend 20% less if I could get, if I had a fraction of a percent chance. So if you look at sort of where all our work comes together, if the mechanisms that Mike are describing can allow us to provide secure computing capabilities. From an AI perspective, there's, yes, we can actually provide much more efficient models. We can, if we're actually sharing data sets, for example, we can cache them, we can make them accessible near it. So that shared of resources, but there's also the enormous potential that AI can do to detect anomalies and problems in the computational infrastructure itself, to actually optimize the use of our infrastructure and detect how we can change it. And that's nowhere near as close to the car running over the cat scenario. I think that's a use case that could be extremely valuable. And in fact, our industry partners are demanding, what can we do with all this telemetry we're gathering from it? So I do see that's a sort of huge area where we can all work together and have a sort of unique perspective at BU.
Fantastic. Maya, Kate, any final comments?
I joke with my students that at this point, I don't even have time to read research papers because all my time is being spent on procuring GPUs. That's my first role. And yeah, I think the environmental aspect of that does bother me, and I just hope that we will invent smarter and more efficient ways of training neural networks and doing AI quickly, so that we don't end up, you know, burning so much energy. And I think there are a lot of people working on that and working on more efficient, both efficient learning, learning with less data as opposed to learning with all of the internet's data. You know, I think currently AI models are very inefficient learners. They need way too much data, way more than a human would need, right? So if you think about it, if AI was as good as humans at learning, you know, we would only need enough energy, that as much energy as we need to power a human child from birth till, you know, whenever they're mature enough. And currently AI is so much more inefficient than that it's not sustainable. So I think we're gonna have to come up with smarter ways of doing AI, basically, that don't use so much energy.
Mayank?
Yeah, so one question that has been a topic of research in computer science going back 4 decades is that of permissionless consensus, right? So if you have a bunch of computers on the internet, how to get them to agree on something, even in a world where, you know, some of the machines involved are dishonest and trying to destroy that consensus. And that's been a topic of research in the literature for a long time. And then someone decided to make that thing that you get consensus over a bank ledger of who has what money, and that became Bitcoin, right? And so that was a way of sort of, it had some innovative techniques of solving this consensus problem, this permissionless consensus problem over the internet for the low price that it takes the energy of like a medium-sized first world country to figure out what that ledger is, which is a horrible trade-off. But there was a lot of work by researchers, including our colleague Sharon Goldberg, in trying to figure out how to achieve permissionless consensus in the world without expending this gigantic amount of energy. It's a very challenging problem, and then tools of cryptography and other aspects of computer science can be brought to bear on that, which address sort of, there is a commercial value to be gained by having a shared ledger, which is why this whole blockchain craze has sort of taken off. There is commercial value there. The question is, can we do that in a way that's more sustainable?
Okay. So the clock has caught us. We're just about at the end of our time here. I want to thank Gloria Waters for allowing us this opportunity to speak to the BU community and talk about Convergence. I want to thank the panelists, Aran, Kate, and Mayank, for joining us, sharing a bit about what you're doing, about opportunities that you're involved with. And I want to just remind those of you in the audience of some of the things that we talked about at the beginning. There's a whole host of ways to get involved with Convergence at the Hariri Institute, anywhere from attending our Did You Know You Could series to the Distinguished Lecture series. Each of the various centers and initiatives that we have often have their own series. So both the Cyber Alliance and security groups have their own seminar series. This is Risk and Cyber Alliance. The AI Research Institute, or AIR, also has its own series, just had a fantastic distinguished speaker last week. And in turn, there's various opportunities to get involved in terms of research, particularly through our focused research programs. If you're a BU faculty member and you have an idea for a sustained year-long thrust involving a substantial group of faculty, reach out to me, get in touch. I'm happy to sit down and talk through ideas. If you're interested in software development, we have a fantastic group with SAIL. So there's a whole host of ways that you might interface with us at the Institute, and we look forward to getting involved with you. So thank you all.
Thank you. Thanks for having me.
Thanks, everyone.
Thanks.
Thanks.